Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and we looked at how the overloading of the native methods work in Java. And so next we can look at how the overriding of the native methods work. And the question is, can we override a native method in a class hierarchy? And the answer is yes, we can. Remember, all methods in Java, even native methods, are virtual methods, which means they can be overridden. And in the bytecode, the invoke virtual is always called, right? And again, JNI uses fully qualified name for C++ methods. So if you have two native methods that override, remember the difference between overload and override is that overload, the signature of the method is the same, the signature of the parameters is different. In override, the methods have exactly the same signature, so the signature of the method and the signature of the parameters, but they belong to different classes. Obviously you cannot have a method in a class and override it in the same class, right? Override means you have a class hierarchy, and override a method from a superclass or an interface, right? But we know that if you go back to how JNI creates the signature of the C++ methods, we know that the class name is part of the signature of the C++ project, right? So we don't actually have the problem that we had with the overloading, because overloading, the package name and the class name was the same, and that's why we saw that the JNI has to add this underscore and then the method signature parameter. Method parameter signature. But for override, there is no problem, because the methods belong to different classes, so they already have different class names, so the signature of them in the C++ is exactly different. It's not exactly identical, it's definitely different, so there is no need for this underscore method parameter signature. All right, so it's a very simple concept. And again, we can override a native method with a non-native method. We can try that and it will work. So let's go to Eclipse and try it. So we had this test overloading, and now I'm going to create another class, test override superclass. All right, so here I'm going to create a method called public public native double func and double x. All right, so this is a function, and I'm going to create another class called test override subclass, and I'm going to say that this extends super, basically test override super class. And then what I want to do, I want to override it. So how do I override it? First, I try to override it with a non-native. Override with a non-native, or basically a regular Java method. So right click, go to source, override implement methods, and func. Okay. And as you can see, Java compiler happily allows us to override it, even though the signature in the superclass was native. Now obviously, because this is a regular Java method, we have to provide a body or an implementation. So let's just return X. All right, now let's say I create a main method here, and I say test override superclass. Test is new test override superclass, and then sysout func dot basically test dot func 1.1. so this is not going to work, because we have not created a dynamic library for this. Basically we haven't implemented this in C++, so this should return or throw a unsatisfied link error, which we see that here. But however, instead of doing this, if I use subtype polymorphism, which means I create a test override subclass, this should still work, or we expect it to work, because this regular method is overriding a native method, and this already has an implementation, and overriding a native method is allowed, so we should have no problem running this. And as you can see, this works. Even though we did not implement this native method, we did not have any dynamic library or have this function implemented in C++. So Java doesn't care, because it goes down the hierarchy, the class hierarchy, and finds the most specific method to be invoked. And this, we know that although this test reference refers to basically is a type of test override superclass, but the actual type of the class is test override subclass, and therefore Java invokes the function which is in the test override subclass, and it already has a body, so Java has no problem. If we go back to Java perspective and look at this bytecode, now what you can see here in this function is that basically if I go to main, and you see when I go here, this is line 16 where we call the function, and it is invoke virtual. So all methods in Java are virtual methods, unlike C++ that a class can have virtual or non-virtual methods. All methods in Java are virtual, which means they can be overridden. So it says invoke virtual test override superclass func. So this is the first one, and invoke virtual yes. So this is still basically calling the function in the superclass, because our reference is a superclass type. This test is a variable reference to the superclass type, but then because it's virtual, it's not invoking the one that we had in the superclass, which was a native that we didn't actually implement. It goes down the hierarchy tree because it looks at the actual type of this class, and it's virtual, so it always climbs down the hierarchy of the class and finds the most specific implementation. So overriding is fine, and we have no problem with that. But then the question is, let's say I have a native method here, and I want to override it with actually a native method again. Override with native method. So let's comment this one, and we have public native double. So the signature should be exactly the same. Actually, okay, I can write it public native double func double x. Again, Java compiler allows us to do that, and as you can see, this is native. In the superclass, it was native, and Java recognizes this as a valid override. We can even add the annotation override. All right. So it's just double check that this function is a native and it's overriding the super type. All right. But now obviously this code is not going to work. It throws the unsatisfied link error, because even though Java climbs down the hierarchy tree and actually invokes the function which is defined in the subclass, it's still a native class and we didn't provide any implementation. So I start from my superclass and use my Java Edge tool, and it's configured to put the header in the header folder in my C++. Okay, and then so it's here, test override subclass superclass, and as you can see, the signature is Java underscore package underscore the superclass underscore function. And I can also go to my subclass, all right, and then run my Java Edge again to create the header file for the subclass. All right, and the signature now is different because it has the test override subclass name. And then I can basically start with this superclass, copy it in my, let's create a new CPP. Let's create a new CPP. let's call it override.cpp, and we want to basically include two header files. Include dot dot, which means climb up from the source folder, one folder up, which goes into the root folder, native C, and then go into header folder, and then test override superclass, and also the test override subclass. Okay, so we add the headers and add the implementation for both the super method here and also the sub method here. So we're adding the implementation basically in the same CPP file for both the superclass method and subclass method, and there is no problem with the method signature because the class name is part of the signature. So the method of even though the method name is the same, the signature is different, right? Because JNI adds this package and class name. So JObject is the superclass here, JDouble is X. Let's say printf S or printf inside superclass and then return X. And here we have the subclass method and X, and let's say printf inside the subclass and return 2x. Okay, inside. All right, so now we need to build this. So let's build it in the debug mode. And it's fine. The library is the dynamic library is successfully generated. We copy and paste it to our project, replace it, and go back to our Java. Where is the so go back to our Java. Let's close all of these in the subclass. Now these two should work just fine. Each one invokes so let's call this test1, test2. Each one of these invocations of the function should basically invoke the corresponding function either in superclass or subclass. So let's see what happens when we run this. It throws an unsatisfied link error because we need to also tell the Java to load the library into memory. And again, we've mentioned this many times, but it's best to use the system load library in a static initializer. And we drop the lib from the beginning of the name and also the extension .lib, so it becomes native underscore C. All right. All right, so as you can see, we have the text. Let's maybe add a new line here, new line, and build it again. Go to C perspective, build it, and copy and paste it to our Java project and run our Java class. 1.1, which was this one in the superclass, 2.2, which was this one in the subclass. Implementation is in C++. What you always notice is that basically the print to the console or to a file or to whatever, basically the streams, the IO streams of Java have precedence over the IO stream in C++ when we're using the JNI. So that's something to have in mind. So here, when I was invoking this method, I asked it to print something to the console. But here, when I run the class, basically the print line of the Java was invoked in the two cases, here and here. So first these two were, and the return type, which was a double, was printed. And then the IO streams or the printf functions of the JNI was invoked. So this is something that you may need to have in mind, to keep it in mind, that IO streams of Java have precedence over the IO streams of C++ when we use the JNI, which means if we have multiple print lines and each print line may call a function that also prints some stuff to the console in C++, whatever we print to the console always executes last, or basically it comes last in the console. Whatever we print to the console in the Java, it comes first. Okay, so just keep that in mind. I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.